As we start chapter 11, we're going to turn to baseball to actually get our point across. Baseball is the one sport that really lends itself the best to statistics. So, using relationships to make predictions. First of all, what we're going to do is look at a model that Bill James, who's kind of the father of sabermetrics, baseball use a lot, and is kind of the idea behind the movie Moneyball in looking at relationships to make predictions. And he found this relationship to predict a team's winning percentage. And this actually doesn't apply to just baseball. But if RS is runs scored and RA is runs allowed, he found out the relationship, as we see in the model, between runs scored squared divided by runs scored squared plus runs against squared gave a pretty accurate idea of a team's winning percentage. So we're going to use this because not all models will square these numbers. So we're going to look at how that works. In the case of the 2008 Phillies, we made that prediction. They scored 799 runs, gave up 680 runs. According to the model, their winning percentage should be 58%, 0.58. If we look at their 162 game season, the model predicted they'd win 93.96 games. They actually won 92. And so the prediction was close, but we come up with the idea of something called a residual. And to calculate a residual, as you see outlined in red, it's the actual value minus the predicted value. So since they actually won 92 games and our model predicted 93.96, the residuals 92 minus 93.96 are negative 1.96 wins. So the model, the predicted missed the actual by about 1.96 wins. And so actually here is the 2008 predictions. You can see for the Toronto Blue Jays, their residual is negative 7.6. You see in the far right-hand column a lot of residuals from the 2008 season. Pretty close. If we go through these, we can see that it really got close for the Oakland Athletics. And then the worst prediction was actually the Los Angeles Angels that year. The residual is 11.5. It missed by 11.5 wins. So it's not perfect. Why did we choose an exponent of 2? Well, the residuals with 2 as the exponent range from negative 7.6 to 11.5. What would have happened if we choose 1 as the exponent instead of 2? Well, then the residuals would have been negative 12.3 to 15.2. So how do we choose the best number? Fortunately, you're not going to have to do any complicated math, but it brings up the idea of the sum of the squared residuals. In order to get rid of the negatives, we take the residuals and we square them. And if we add them all together, that's the sum of the squared residuals. We're trying to get the lowest number possible. And whatever lowest number is the exponent we'd use to make the prediction. So let's see what a graph of that looks like. Here's the graph of the different exponents. You can see the arrow points to an exponent of 1.0, and the sum of the squared residuals was a little over 1,200. Can we do better than that? Well, if you look through the different exponents, we can see down somewhere near 2, and it's hard to see on the graph. Looks like 1.9 or 2 look like the best because they're the smallest numbers, below 500. And we actually show you that the number 2 is 529, but 1.9 was 527. So actually 1.9 would have been a better exponent. It's at the bottom of that chart. It's the one that minimizes the sum of the squared residuals. So just for your information, here's predictions for 2015. But anyway, let's go through and look at what other factors could influence. Well, something else that comes up in baseball is a statistic now they called WAR. And here's that. It's just called wins above replacement. Don't worry, we won't be responsible for it, but you kind of see this a lot of times in baseball. We're going to read an article about Mike Trout and that, and how much better a player is than a team would typically have to if they replaced him with another player. So how much better is this player than the replacement player? And there's the complicated formula. Don't worry, it's beyond the scope of this class, but just to give you an idea, that's a popular statistic they're using in baseball right now. Anyway, we're going to go through this one problem predicting the winning percentage of the WNBA. We're looking at the Los Angeles Sparks in 2010. And anyway, here's their chart. If we look at their chart of the exponents and the sum of the squares residuals, which exponent do you think would minimize the sum of the squared residuals? And if you look at the bottom, it looks like the exponent of 12 would be the best. Okay? The exponent of 9 gives a very big number, so that just shows you on average how far off the prediction would be. So anyway, using 12, okay, we'll look at the calculation here. If we use 12, and if we use the model with 12 as the exponent, using points scored, 77.9, points against, 81.2, we got a predicted winning percentage of 0.378 or 37.8%. And if they play 34 games, that means we would predict the Los Angeles Sparks would win 12.85 games. Okay? So that's their prediction. What they actually get? Well, they won 13 games. So what's their residual? The residual is actual, 13 minus predicted. Oops, I did the opposite. So the residual should be actually positive 0.15. And what does that mean? The predicted number of wins for the Los Angeles Sparks in the 2010 season was 0.15 wins above, below the actual number of wins. So anyway, there's kind of an idea. You've got a couple problems to do in the book, numbers 1 and 3. So go to your text and look those up, or I might post a copy of that on the website. But please work on those in class, and that'll be due next class. Have fun!